Here we are on page 22 with the solutions to number 16 through 27. It says find the missing variable for the right triangles. And since it's got right triangles, we are going to use SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So those will be our basic things that will give us equations to solve here. So let's get to it. Number 16. Says we have C is 13 and theta is 26. Well, good, let's write out what those will look like. We have sine of 26 equals A over 13. That's opposite over hypotenuse. Good. Cosine of 26 is going to equal B over 13, and tangent of 26 is going to equal A over B. Well, we don't know A over B. We can't solve that guy, so that's not as valuable. But these two we can stick in our calculator. So let's pull up that calculator, and we're going to have right here 13 times the sine of 26. So 13 times 26 sine equals, and this is 5.699. So 5.7 is going to be A. 5.7. Okay, and B, 13 times the cosine of 26. So we get 13 times 26 cosine, not sine, and that equals 11.68. 11.68. Okay, that's good. And now, what else do we get here? Alpha. Well, theta and alpha have to add up to 90, so that would be 90 minus 26 is 64. Oh, good. Okay, let's try number 17. It's got C is not 13, it's 5, and it says alpha is 58. So everything here in red. So let's write those down. We have sine of 58 would be its opposite, which is B over 5. Hey, we can solve that guy. Cosine of 58 is going to equal A over 5. And then tangent is going to be B over A, which won't give us an equation we can solve. So let's stick these into the calculator. 5 times the sine of 58, 58 sine, good, equals, and we get 4.24 is B, 4.24. Okay, now we'll stick in 5 times the cosine of 58, 58 cosine times 5 equals, we get 2.649, 2.65, 2.65. And can we get theta? Sure we can. Theta is 58 from 90, gives us 32. Now we should note that once we had B, 4.24, we rounded a little bit, but we could have done 5 squared minus 4.24 squared to get A squared. And let's just run through that one time for illustration purposes. We'll be off by just a couple of decimals because we rounded, but minus 4.24 squared equals, and now square root that puppy. What do we get? 2.65. Wow, now it is off by a couple of decimals if you were to compare it to what we had before, but notice that the Pythagorean theorem will work with all of these all the time. Okay, let's look at number 18, and let's clear a few things first. Okay, so number 18. Here we have A is 7 and theta is 20. Can we write those out? Yeah, what's sine of 20? Well, that gives us 7 over C. Cosine of 20 would get us B over C. And tangent of 20, what will that give us? Tangent of 20 will give us opposite, which is 7 over adjacent, which is B. Notice that this time it's cosine that isn't very valuable for us. It has 2 variables in it. So let's go ahead and do the others. Here we would times C up here and then divide by the sine of 20 down below. So this is a division one that we had to work on. So let's pull that out and see if we get it. Okay. We get 7 divided by the sine of 20. 20 sine, and that equals 20.47 is C. 20.47. Good. Now let's see if we can find b. We're going to do the same thing, times b up here, and then tangent of 20 down there. So we're going to type in 7 divided by the tangent of 20. That's going to equal b. All right, let's punch that in. 7 divided by the tangent of 20 equals, 19.23. 19.23. And notice we can kind of double check that we've got this right. The hypotenuse, C, always has to be the longest side. And B does indeed look larger. And of course, alpha is 70 degrees. So that makes sense that this guy is opposite the largest side, the largest leg. That's opposite the smallest one. And of course, the 90 is opposite the very longest, the hypotenuse. All right, let's try another one. Number 19. We have A, in this case, isn't 7. It is, well, we don't know what it is, but B is 12, and alpha is 39. So alpha up here is going to be 39. And, okay, we don't know what theta is. Oh, we could find it. It looks like it's going to be 51, right? If we take and subtract that from 90, we get 51. Okay, so let's write these out. The sine of 39, okay, so the 39's up here. The sine would be 12 over c. We can solve that equation. What about the cosine of 39? That would be a over c. We don't know that one. And then tangent of 39, opposite over adjacent. So opposite would be 12 over adjacent, which is a. All right, can we solve those? Certainly we can. We can times the c up here and the sine of 39 down there. So 12 divided by the sine of 39. Let's bring the calculator out, move it over. 12 divided by the sine of 39. And that equals 19.07. 19.07. Alrighty. And then A. Looks like cosine of 39, not so much. Tangent of 39, 12 divided by the tangent of 39. Again, multiply the A up here and then divide by the tangent of 39. 12 divided by 39 tangent equals, and we get 14.82. 14.82. If we have 14.82 here, now notice this looks bigger than that big long side here, and that came because the labeling was a little bit weird. They had a 39 even though it was not the larger of the two angles up there. So this triangle is not drawn to scale. All right, let's get those cleared off and do number 20. Here we have B and C, but we don't have any angles. Ooh, that's interesting. Notice we can use the a squared plus b squared equals c squared, 25 squared. So that's going to be a squared plus 225 minus 625. Is subtract that over and we get 400. So a is going to be 20. Hey, that's nice. We already got that one. Now to get alpha or theta. So if we've got a is 20 and this is 15 and this is 25. Again, look, it's not drawn to scale very much, but let's go ahead and do that. Well, let's write out to find alpha. If we wrote sine of alpha, that is opposite 15 over, so opposite of alpha is 15 over the hypotenuse of 25. We know how to solve this. We punch in 15 divided by 25 into our calculator, and then we inverse sine, and it goes backwards and finds that angle, 36.87. So in this case, alpha is 36.87. And so theta, we can either subtract this from 90 or we could do the same thing. Let's try tangent of theta. That would equal 20 over 15. All right, and so our calculator, if we did that, 20 divided by 15, oh boy, inverse tangent. And we get 53.13. Now notice what happens here, 53.13. These two would have added up to 90 anyway. So in future reference, we could have subtracted from 90 if we wanted to, or solve it by an equation. That's perfectly fine. All right, let's try number 21. We have A is 13, B is 20, and so C we're going to use a squared plus b squared equals c squared. Certainly 13 squared plus 20 squared equals c squared. Alrighty, so what does that get us down here? 169 plus 400 equals c squared. C squared would then equal, looks like 569. So we pull up that calculator and hit the square root of 569. 569 square root, so we get 23.85. 23.85 will be C. 23.85. Now notice we rounded that to the nearest hundredth, so that won't be incredibly accurate to use later on. So let's go ahead and use one of these guys. Try to find, say, theta. If we do sine of theta, we'll be using A over C. Cosine of theta will be B over C. And so let's use tangent of theta. They'll all get us the same thing, but this is a rounded number, so it'll be easier to use these guys. 13 over 20. All right, let's punch that on our calculator. 13 over 20 and inverse tangent. 13 divided by 20 equals, and then inverse tangent. And we get 33.02 degrees. That's alpha. That's theta, 33.02 degrees, 33.02. So what does that make alpha? Well, we subtract it from 90. I'm just going to subtract 90 here and we'll get a negative number, but 56.98. 56.98. Good, let's clear those off and look at number 22. We have A and C, so we need to use A squared plus B squared equals C squared. So we get 21 squared plus B squared equals 67 squared. Ooh, so let's get our calculator out. 67 squared minus 21 squared equals 4,048. And we square root it and we get 63.62. So B is going to be 63.62. Good. All right, so alpha and theta. Let's look at theta right here. Sine would be A over C. Cosine would be B over C, and tangent would be A over B. And we have A and C. So let's go ahead and use sine. Sine of theta equals 21 over 67. That's good. Plug that into our calculator here. 21 divided by 67 equals inverse sine. We get 18.27 degrees. 18.27, and if we subtract that from 90, we get that theta must have been 71.73. Good. All right, the last one. We have B is 57. Let's put that up here. And alpha is 72 degrees. Oh, we can get theta. We can see that one's nice and easy. We add those up to 92, so we just need A and C. So if we take sine of 72, that is going to be 57 over C. Multiply by C, divide by sine of 72, and we get, let's pull out the calculator, 57 divided by 72 sine equals, and we get 59.93 for C, 59.93. We could use A squared plus B squared equals C squared here, or we can use tangent. Tangent of 72 equals 57 over B. And note, we could use almost any tool here. Cosine of 18, sine of 18, cosine of 72, we could use any of those. But let's go ahead and use this one. 57 divided by the tangent of 72. 57 divided by 72 tangent equals 18.52. Okay, so A is 18.52 and B is 57 and C would be 59.93. Good. Now down to number 24. In flying a kite, there's 55 feet of string. Well, that tells us that's the hypotenuse right there. If here's the kite and here's the ground, that makes a 27-degree angle right there, 27 degrees. And how high? So here's our x. So if we do cosine of 27, we'll find this side. So we want to use sine of 27 equals x over 55. And we see how powerful these trig ratios are in the calculator. So we're going to punch in 55 times the sine of 27. That gets us 24.97. Answer is 24.97 feet above the ground. So about 25 feet above the ground is how high that kite would be. Okay, number 25. A trolley climbs 18 feet vertically up a mountain. So trolley's headed up the mountain and it travels up vertical 18 feet. And it went a horizontal distance of 327 feet. And it's asking for the angle of elevation, so it wants this alpha right in here. So we could find the distance it traveled by 327 squared plus 18 squared and square root it. If we did sine of alpha, we'd involve c. If we use tangent of alpha, that will involve the opposite over adjacent right there. So we can solve for it. Let's put that one right there, and we get 18 divided by 327.055. Now we do the inverse tangent of that, and we get 3.15. So the alpha is 3.15 degrees angle of elevation. Not too bad there. All right, let's get rid of those. And number 26. Point on the ground 72 feet away from a fountain. So here's a fountain coming up here. And oh yeah, look at that. All that nice water spewing out. Okay, so we've got a point on the ground 72 feet. Right there, 72 feet. Has an angle to the top of the fountain of 38 degrees. It says how tall is the fountain? There's our x right there. Well, we're dealing with from 38 degrees, it's opposite and it's adjacent side, so that immediately tells us, hey, we're going to use tangent of 38 equals x over 72. Can we solve that? Yeah, multiply both sides by 72. So we get tangent of 38 times 72. 56.25. So 56.25 feet. That's how tall the fountain is. Number 27. A plane is 10,000 feet off the ground. So if we have an airplane right up here and it's 10,000 feet off of the ground right here, let's draw that down here, 10,000 feet. The angle of depression to one town The angle of depression to one town on the east of the plane is 79 degrees. So if we were horizontal, depression means that we go down 79 degrees. So what that means is we have 11 degrees almost straight down to this town, one right here. There we go. Then it says the angle of depression to another town is 43 degrees further east. So over here, and you go down 43 degrees to get to that guy. So 43 here would be 47 in here, 47 degrees in there. So you got to be careful with those two angles there. So we've got to find out what is the distance between the two towns. So we've got to find out this. Well, maybe you can see it, but we've got really one triangle here. Okay, there we go. The red one with an 11 degree in there and 10,000 over here. And then we have a blue one, which is this guy right here. Yeah, and so the difference between these two sides is what we need. So let's do the first one. Tangent of 11 degrees equals x over 10,000. What do we get there? Calculator time. Tangent of 11 times 10,000. Yeah, we get 1,943.8 feet. That's 1,943.8 feet. Okay, now the big one, let's do this in blue. We have tangent of 47 degrees equals x over 10,000. So we just use the same thing in both triangles to see this bottom side down here. This is a different, we'll call that guy y. Okay, this big long distance down here, and use our calculator, and we get 47 tangent times 10, 1, 2, 3, and we get 10,723 feet. So 10,723 point what? 0.7 feet. Okay, so now that's the distance from straight under the plane over to this other town. So if we subtract those two, we will get the distance between the towns. So subtract the 1943.8, 943.8, and we get that the distance between them is 8,779 feet. 0.9. So 8,780 feet. We can round to the nearest foot, that's all right. Feet. So just about 1.5 miles away from them. Good.